Hello, everyone. Today we're going to do our quick video for our last lesson in unit number 4. This is where we're going to work on solving right triangles again. This time we're going to be looking at some situations where we're not given um, any of the or either of the acute angles. We only know that this is a right triangle because we were given a right angle. It just changes a little bit of how we approach this. Not a whole lot. Um, and so again, there's multiple different paths we can take to get to our answers. Again, I'll try and show you one way, but hopefully you can see that there are some different options there as well. The first problem here, we see triangle RST. We're given, well, one side is 5 and the hypotenuse is 6. So we need the other side and the two missing angles. I'll show you how to do this in order. Again, you could do this in some different ways if you want, but I think that this way gives us the most options. So I'm going to label this SR side question mark, and we can use the Pythagorean theorem to figure out the missing piece. So we're going to have our missing side squared plus 5 squared is equal to 6 squared. Okay. This means that we're going to have our missing side squared plus 25 is equal to 36. We subtract 25 from both sides. We're going to have our missing side is going to equal 36 minus 25. That's 11. And so we know that our missing side will be the square root of 11, right? Now, it's asking us to round to the nearest tenth. So we're going to need our calculator here. We'll do the square root of 11, and we should get about 3.3 for our side length. Okay, that is totally accurate answer. I'm going to kind of undo that, and we'll say that that's 3.3. Now, I don't want to use that number in any of my other calculations because I had to round it. So I'm just going to use the 6 and the 5 from here on out. So hopefully that makes sense to you, because again, if you use 3.3 in any of your calculations, it's going to be a little tricky because you're going to have to round, and you may round incorrectly based off of 3.3 rounding. That could give you an incorrect answer. So let me switch my color here. So angle T is down here. So to find angle T, I'm going to use sides 5 and 6. So again, we're going to need to use SOHCAHTOA. So I'm going to write this up here at the top, SOHCAHTOA. So based off of angle T, 6 is the hypotenuse, 5 is the adjacent side. So this is cosine. So we would say for angle T, the cosine of angle T is going to equal 5 over 6, which means that the measurement of angle T is going to be the inverse cosine of 5 over 6. Right, so this is where we have to use the inverse trig function. Again, we'll just do, if you make sure you're in degree mode, again, this is very important. If you're using Desmos, just make sure it's selected to degree. It's under the wrench, the tool. The inverse cosine of 5, 6 registers around 33.5 degrees. This is 33.56 degrees. So when this rounds to the nearest tenth, this is going to be 33.6. So this is preferable to using 3.3 as the side. Again, you could use the square root of 11 as the side, and that would be okay for the blue side, but I'm not going to worry about that. Sorry. And then we'll go back to here, and we'll do our very last bit, which is angle S, right? So angle S, we could just do 90 minus that. That would totally work. We could also approach this from looking at this from the sine. What I would recommend is if you've got this number in your calculator already, right? Don't use the rounded version. Please don't use that. But you can just do 90 minus the inverse cosine of 5, 6, right? So if I do that, if I do 90 minus the inverse cosine of 5 over 6. It's going to give me an answer with a bunch of decimals, and I'm avoiding any problems from rounding. And so this one I have is 56.44 degrees, which thankfully it does actually work. I could have just done 90 minus because this ends up being 56.4, and those add up. Just be careful with that because sometimes it may not, depending on how close the rounding is. It could be potentially off just a little bit. All right, we'll try that one more time. Well, a couple more times. I'll give you a couple more examples. Again, we're focusing a lot on what do we have and how do we solve for missing pieces. So I'm going to do kind of the same thing that I did last time. I'm going to solve for our missing side first. This is our missing side. So I'm going to get, using the Pythagorean theorem, I'm going to get our missing side squared plus 7 squared is equal to 8 squared. This is going to be question mark squared plus 49 is equal to 64. Our missing side is therefore going to be 15. Again, that's 64 minus 49. And this tells us that our missing side is the square root of 15. Okay, so we can find the decimal for that. Again, the square root of 15 is 3.87. Which rounded to the nearest tenth would be 3.9. Right, so I have that as 3.9. Now, again, I'm not going to use that number for anything. I'm now going to find, oops, that's the wrong one to connect to. Sorry about that. We're going to find angle S now. Again, for angle S, we see sides 7 and 8. Okay, 7 and 8. 8 is the hypotenuse. 7 would be the adjacent sides, kind of like we've seen this before. Adjacent and hypotenuse use cosine, so we're going to say the cosine of angle S is going to equal 7 over 8. And so the measurement of angle S will be the inverse cosine of 7/8. Right, and so we can, again, type that in, inverse cosine of 7 over 8. We get 28.96 degrees, right? So this would round as 28 or 29. Sorry, 29 degrees, right? It rounds up to the 10th, so 29.0 would be the right here, right? So this is where now I think we'll see why you might not want to just use the 29. Hold on, I think maybe my brain might be working right. So what we're going to do here is we're going to do 90 minus the inverse cosine of 7/8, right? So this is just the complement of that, right? What goes with 29. And so we're going to do 1 minus that. Oops, sorry, or 90 minus, sorry, the inverse cosine of 7 over 8. And we get 61.04, right? 61.04 degrees, which will round down to 61, right? So it does make sense that we can use the rounded down version here. Again, you're rounding to the nearest tenth, so 04 would round down, 05 would round up to 0.1, but we don't get that here. So again, similar to the last problem, we can use the Pythagorean theorem to find our missing side, and then the angles, we're going to have to use inverse functions. It's the only way to do it. We could actually find the missing sides a little bit differently. We could choose to do cosine or like a regular trigonometric function to do that, to find a missing side once we have one of the angles. But I'd prefer to just use the information in the problem to solve for everything. I think that's the cleanest way. One more, and then we'll be done for today. So again, we're going to use SOHCAHTOA. So keep that in mind, and we'll do the Pythagorean theorem again one more time. Again, for the Pythagorean theorem, this time we're finding the hypotenuse, right? So that's good, right? That makes it easy. So we're going to say 4 squared plus 7.9 squared is equal to our unknown squared. So this is 16 plus, now 7.9 is not a number I know off the top of my head, so this is 62.41. That equals our unknown squared. Our unknown squared, when we add this together, should be 78.41, which means that our unknown is going to be the square root of 78.41. Right, so remember, we always have to take that square root at the end. So the square root of 78.41, this ends up being 8.85, which is going to round up to 8.9. Okay. Again, that's not exact. It's a rounded answer. The correct answer would be the square root of 78.41. But they're asking to be rounded to the 10th. So now we're going to move on and we're going to look at the missing angles. Angle E is the one they ask for first. Again, I'm going to use the answers they give us because they're not rounded, or the parts that are not rounded. These are the two sides, 4 and 7.9. 7.9 is the opposite side, 4 is the adjacent side. So this is tangent. So I would say here the tangent of angle E is going to equal 7.9 divided by 4, which means that the measurement of angle E is going to be the inverse tangent of 7.9 over 4. So again, you'll need a calculator for this. Just make sure you're in degree mode because that's how it wants us to answer. So I get here 63.15 degrees, right? It says 14 on my screen, but the digit after that actually rounds up to a 5. So, well, hold on a second. No, actually, this should round down, right? So, sorry about that. This would be 4.5. So we would round this down to 63.1 degrees, right? So again, this one's really, really close to on the line, so I almost kind of made that mistake. But again, technically this would round down to that. We haven't had one that was quite that close yet. And then we get to our last part here. And this one is going to be 90 minus the inverse tan of 7.9 over 4. That is going to give us 90 minus our answer here, 26.85, which is going to round it up to 26.9. And hence fitting that, right? So again, this is just to be a little more precise this way. You could have used in each of the examples, you could have used the measure of the first angle, just do 90 minus that rounded to get it. Again, just maybe a habit of mine that I always try to use as exact answer as possible. But yeah, that's it. So your choice to find the missing side is kind of up to you. The Pythagorean theorem is a pretty simple way to do it. If you like using the trigonometric approach, where you say like the cosine of, of 63.1 equals this, you can find a missing side that way. Again, it's just personal preference at that point. Pythagorean theorem's super fine and works all the time, so that's why I've used it.